if you are confident that you have studied a particular synthesis and till the evening you remember all the reagents and all the raw materials, it is not necessary that after a day or two you will be able to recapitulate it easily. It needs thorough practice every day. A taste struck with glance is very, very essential for organic chemistry, right? Because this is a volatile chemistry. So now let us begin. Since it is 11 o'clock and I have 35 students, okay, since they are coming, okay. So yesterday also I had recapitulated you that few positions are very, very good for electrophilic substitution, right? The positions are 5 and 8 for quinoline and isoquinoline, and the position for pyridine N oxide is 2, 4 and 6, right? I'm talking about electrophilic substitution. Is this very much clear to everyone?
Yes, ma'am.
Okay. So now, today we are going to start with another synthesis. Yesterday I have taught you quinoline synthesis, and today I am teaching you isoquinoline. Isoquinoline. The synthesis is very, very easy to remember also. I am jotting it down very, very fast. Please pay attention to me. First step, I am going to use benzaldehyde. I am going to use benzaldehyde. And I am going to react it with nitromethane. Formula CH3NO2. Let me write down the names. Benzaldehyde, and nitromethane. Okay, this will basically be a condensation reaction. A condensation reaction is always... Yes, yeah?
Ma'am, blur दिख रहा है पूरा.
Is it?
हाँ ma'am.
Okay, I'll rejoin the meeting again.
Yes, ma'am.
Am I better now? Children?
Yes, ma'am. Yes, ma'am.
Okay, fine. So let's begin. Now this is nitromethane. This reaction is going to undergo condensation reaction. Always remember, condensation reaction means elimination of water molecules. So I need to remove the water molecules. So 2 hydrogens from here and 1 oxygen from here will be eliminated. Someone is late. Apeksha is late today. Okay. Now, once I have removed the water molecules, I am going to jot it down on my arrowhead. And I'm going to write down the compressed structure. So this is going to be benzaldehyde. I can write it in this way also, right? Okay. So double bond O has gone away. Now I will have double bond formation between this carbon and this carbon. So this is going to be this way with the hydrogen over here still. Now this carbon has already shaken a double bond over here. It has lost 2 hydrogens, so 1 hydrogen is remaining. Now the other valency is satisfied by nitro group. Right. Okay. Now this structure is very, very similar to styrene structure. So that is why its name becomes alpha beta. Have you heard about alpha, beta, omega? Anyone?
Yes, ma'am.
Yes. So those nomenclatures are also used in organic chemistry. So alpha, beta, omega. Alpha, beta, omega. Right? So now the nomenclature will go this way. Alpha, omega, nitro, styrene. This structure is very similar to styrene. So omega, nitro, styrene. Now the second step will be, you have synthesized the structure But what is your compound which you need is this. The compound which you need is isoquinoline. So this is going to be your final structure where you have to arrive. उसमें से एक बेंजीन रिंग तो आपके पास मिल ही गया है. अभी आपका what is your job to synthesize this part of the aromatic structure. So we are also nearing that now. So दो carbon atoms we have already got. Let us emphasize on this part now. Here I am going to now undergo reduction reaction. Reduction reaction involves addition of hydrogen or removal of oxygens, right? So this reduction, we have to use a very, very strong reducing agent called as lithium aluminium hydride. Lithium aluminium hydride. It's going to reduce this. It's going to reduce this unsaturation, as well as it is going to reduce this NO2 group. I said it is addition of hydrogen or removal of oxygen. In this process, both are taking place. So let us study the synthesis in the next step. The structure will be in this fashion. My benzene ring is already over here. Then I have got my carbon. I have got the hydrogen. I have got my carbon over here. Now, this double bond has been broken. So I will have CH2 over here and I will have CH2 over here. This nitro is now converted into amino group. It's now converted into amino group. Right. So I will write here it is beta. Beta phenyl. Anyone the name? Beta phenyl. This is ethyl group. So ethylamine. Ethylamine. Okay. Now, this is the second step. First, what I did, condensation step. Second step is reduction. Now, if I want to obtain this kind of a structure, I need to have one more carbon atom over here to join to this carbon atom which is already there. So that means what? I have to have one more carbon atom. मतलब मुझे उसको acylate करने की ज़रूरत है. I have to add one alkyl group which will be done using acetylation. So the next step is going to be your acetylation. Acetylation. Acetylation involves addition of RC double bond OCl. Acetylation involves RC double bond OCl. So what is going to take place is, you can see the hydrogen over here. You can see chlorine over here. So elimination of one hydrogen from here and chlorine from here. So it will be minus HCl. Right. After that, I'm going to just recombine the structures and I will be getting, this is your benzyl group. Already you have your CH2 structure. This is a CH2. This is your nitrogen. Right. This nitrogen still has one hydrogen. Pay attention. And now what I have joined is your C double bond OR. So it is C double bond OR. Right? Okay. I was successful in putting one more carbon at this position so that my final structure will be cleared. ठीक है, इधर तक तो समझ में आया. Now, can you see this is a ketonic group, everyone? Yes. This ketonic group can be formed by undergoing keto-enol tautomerism. It is keto-enol tautomerism. So, इसका structure will be this way. Okay. N double bond C, then OH, and then R. Right? This is nothing but keto-enol tautomerism. Okay. Till here, is it clear to everyone?
Yes, ma'am.
Yes.
Yes, ma'am.
Tautomerism पर समझ में आया है. I need to get rid of this group. So that means now I can figure out that if I need to join this carbon atom to this carbon atom, I can eliminate this hydrogen sitting over here. So what will I do? I am going to straight away go for removal of this water using a reagent called as PCl5. Okay, the reagent is PCl5. Reagent is PCl5, which will remove one water molecule over here. Fine. Now this water molecule is removed. I need to recombine the structure, and it is going to be benzene ring, my cyclization, and there is a double bond over here. This carbon has formed a bond over here. Anything remaining, bacha log? No. So this has undergone cyclization. Cyclization. Okay. Now, still yet I have not achieved what I wanted. The structure line in front of it is isoquinoline, and I am able to synthesize a two ring membered ring. Now, I need to have a double bond at this position. So a double bond at this position it will be obtained by using palladium as a catalyst for removing the hydrogens. Like I have to remove the hydrogen over here and over here. This takes place at 100 degrees Celsius. This takes place at 100 degrees Celsius. So finally I can see my hydrogens have gone away. Right? My hydrogens have gone away. And now my final structure, I am going to synthesize finally my isoquinoline. Isoquinoline. This is the structure of my isoquinoline. Fine. I'll repeat to you once more synthesis of isoquinoline. Okay. First step is going to be a condensation step. First step is going to be a condensation step. Now, in this condensation reaction, I have to eliminate water molecules. Fine. Now, nitromethane is going to give me 2 hydrogens, and oxygen I am going to receive from benzaldehyde. Combination of them will give me a structure which is called as omega nitrostyrene. Why? Because this structure is very similar to styrene. I am going to do reduction. Why is reduction needed? So that somehow or the other I am going to get this formation of the ring, which can be achieved by reducing this nitro and this unsaturation also. Once I have reduced, I am getting a structure called as beta phenyl ethyl amine. Okay. This, what I want to do, why I am doing the next step is because I want a linkage over here. I want one more carbon over here. So how can I achieve that? I can achieve using acetylation. Acetylation, always remember it is done using acetyl chloride, RC double bond OCl. Now, you will eliminate chlorine from here and 1 hydrogen from here. This is going to give rise to a structure like this. But I can resemble this structure with my keto and enol tautomerism. So once this undergoes tautomerism, one thing is very simple for me to achieve. I can see the hydrogen over here. I can see the OH group over here. I can remove this using a reagent called as PCl5, phosphorus pentachloride. And this is undergoing cyclization to form a structure which is similar to isoquinoline. Now, what is left to be achieved is this double bond. So this double bond can be achieved using palladium as a catalyst on carbon support. And that takes place at 100 degrees Celsius. And finally, my synthesis of isoquinoline is achieved. Is this clear to everyone, bacha log?